like the
programming language.
Straight after that. Not through, but
Yeah, it doesn't make any sense. Because here, right, open source is greater.
yeah.
Ooh, who's rubber duck?
Yeah, no, because I was just. Why you can't
Rubber
say
duck?
words they can't say.
These are
String manipulation, big boy.
Well, but still, but my other ones don't.
I get motion
So
sick,
like,
but-
Listen, after class, all right, let's do it the integer division way. Seriously,
So the spinning.
like that's crazy to try to do that.
Free chair rental?
And then we went to some bars
God.
after.
Yeah, the string ends.
Yeah.
No, you can't do that. You cannot.
How are you gonna do it?
One of these Chinese sunglasses.
But it
Amazing.
works, unfortunately.
And a
I
duck.
wish it would have been in the right order.
A big cluster here, very
Sparse.
flat, very sparse
Yeah.
cluster here. I don't know why. It's like it happens. Maybe these guys here are online. Okay. So today I want to go back to Scala, talk about some of the terminology and some specific object-oriented aspects of Scala, because I think kind of rushed when I discussed this. And it's going to be helpful for you're going to start coding Scala. The first programming assignment will be assigned soon. So I want you guys to be comfortable with this new language. New for, I believe, for most of you. So one of the things I may have skipped the specific terminology used in Scala is when Scala defines constructors. There's this thing called primary constructor. So in Java, you guys were used to default constructor, right? It's parameter-less constructor or constructor without parameters. And if you don't specify a constructor, Java will provide one for you, the one without parameters. And you have parameterized constructors that you can add and create on your own. But Scala has this thing called primary constructor, okay? And primary constructor is definition is embedded or mixed together with the class definition line. The first line when you create a class in Scala, like the first line when you define your class, so class, and then you name your class, this is basically where you specify the shape of this primary constructor. So for example, this rectangle, you don't see any parentheses and with parameters after the name, right? Rectangle. It means that the primary constructor is parameterless or will not take any parameter. And then the code for this primary constructor, it will be embedded within the class body, right? And it's not inside any particular method, right? Like how we use in Java. The code for a constructor is actually embedded, for the primary constructor is embedded in the class body.
That seems like a lot more work for the syntax analyzer.
Yeah, but I mean, it's convenient for the programmer, the user of that's writing the class, right? Because you don't have to, you write less. That's what this benefit of this primary constructor, in my opinion. You write less. You don't have to create a specific constructor. It's embedded in the class body, so you end up writing less. If you want to add other constructors, secondary constructors, you use this. So this is a function definition, because you're using this is understood that this is a constructor. Okay, and it's not the primary. It's a secondary constructor, right? Of course, you can only have one primary constructor, right? Because there's only one way to specify this initial constructor, right? So you can only have one primary constructor, but you can have as many other constructors as you want if you use this syntax. Okay, so this example here, for example, here, again, class rectangle, using a parameterless as the primary constructor, okay, and just using data encapsulation, using the private, right? So these are instance variables, and they will be hidden and internal, so they will not be users of our rectangle class will not be able to access these instance variables directly because of the private constraint. See other example here. This is another example. This primary constructor here is not parameterless. It actually has two parameters, right? The ID and the name. So in the class definition, you enumerate parameters for your primary constructor. So those are the two parameters, and I'm not explicitly setting any initial values. So ID is an integer, we'll probably set to 0. Name is a string, will be set to null. So, oh, here's an example of method override. So toString, again, similar to Java, if you don't specify the parent class of your class, it's assumed it's the object class. It's slightly different in Scala. I'm going to show you the class hierarchy used by Scala, but toString is inherited, and you can override. You need to add the override keyword. In Java, this was something that was added later using annotations, right? The add override, but in Scala, it's a keyword override. If the code for your function or method can be written in one line, you don't need to define a block for your function. You can just set equal, and then you specify what your function is returning, for example. The difference between this one and this one, actually using private, right? So encapsulated. Oh, this is basically doing parameter validation, right? So if you want to make a distinction, if you need to make a distinction between ID parameter and ID instance variable, you prefix with this. That's similar to Java. Another thing that I wanted to mention is this thing called companion objects. Okay, so we discussed previously the singleton objects, right? So a singleton object in Scala is a class that can only have one instance, so it can only be instantiated once, right? So they are called singleton objects. What is a companion object? So a companion object is a singleton object. Okay, it's a singleton object that has the same name of your class, and you're going to create the singleton object in the same file where you create your class. So, for example, this rectangle class still, okay, this is too small, but you see you have this rectangle class, okay, and this is just one file, okay? This rectangle class, I want to, for example, I want to define static or class variables, right? Class variables. This default measure, I want it to be a class variable because I don't want to create this variable to each instance of my rectangle class. I just want to create one. So in order to do that, the best way to do that in Scala is within the same file where you create the rectangle class, you're also going to create this rectangle object. So this is a singleton object, and it is also a companion object because it's a singleton object created in the same file where you create the class with the same name. That's where you're going to specify your class variables. Okay, so in Java you use static, right, to create class variables, right? If it's usually they are constants, you use static and final. In Scala, you would do a companion object or a singleton object in the same file of your class variable class definition, and you use vol, for example, because in replacing final, right? So where is the static? The static is assumed because where this variable was created, it was created in a singleton object. So you can only have one instance of this definition here, okay? Another thing, inheritance. Inheritance is very similar to Java. You just put, see an example, have vehicle, and you want to define car. So you just use extends. So similar to Java. How about, this is the class hierarchy. In Scala, it's slightly different. The parent of all classes in Scala is called any. Okay? So any can be any vol or any ref. So any vol are for those, although it's, you see class names, right? But they are reserved for those built-in types, right? For efficiency, right? For some types that require efficiency, like numerical values, right? So those are implemented using and this. They are all inherent. They are all defined as specializations of any vol. And all the other types, class types, they come from any ref. There's also this thing called option container class. Okay? So a container class is option T, and this is generics, right? So it supports generics. T can be any type. Option T can be some T or none. It's best to understand with an example. For example, let's say you want to search a map based on this type. K is the key, V is the value type. Okay, and you're going to search for a key. It might be the case that the key does not exist in that map. In those cases, the search returns an option V. Okay, so option V can be some T. Some T means the key was found, or can be none. So none is when the key is not found. So let's see an example here. usually this is the way you search for a key in Scala. So employees is a map that the keys are string and the values are integers. So for each name, I want to associate a number. And I want to search Bob, for example, the key Bob in employees. And as we see here, Bob is not a valid key. So I use the match pattern construct. In case the return of get Bob is option int, right? Option int can be some int or can be none. So if it's none, it means that Bob was not found. The key is not valid or the key is not mapped in the map. If it's found, it's going to be some integer, and we can use a variable to get the actual value associated with the key. So salary is a variable, and I can say Bob's salary is 7. Okay. So I wanted to show you this option T in case you, in your project, you need to use a map. And for the lexical analyzer, I actually, for the homework, I suggested a map, right, for the keywords, to associate the keyword with the token value, right? So it's easy to use a map. So in case you end up having to deal with a map and you have to work with the option T, please refer to this part of the guide so you learn how option T works. And finally, I wanted to talk about interfaces in Scala. They're called traits, and they're basically, it's just another name for interfaces in Scala. For example, I think it was Spider-Man, okay, ability to jump is an interface. It's called a trait. So it defines just a function called jump. And if I want Spider-Man to have the ability to jump, I would say, when I define the class, I would say with ability to jump. And then I do an override for the jump method. So it's essentially the same thing as interface in Java, okay? So nothing new here. All right, so I wanted to do this quick discussion on particularities in Scala, and let's do a short quiz to see if you guys retained any of what I said.
That's been a while.
Yeah, it's a good moment to do good technique to help you retain the information. If I just ask questions about what I just said, it's going to help you to retain. All right, so let me get this ready.
Let me charge my.
You know that this thing has a nice cool. Have a little juice. This doesn't last for long. About 45 minutes. You should say thank you.
My data mining students, they got 100% in the same class. The same. You guys got 0.
We're gonna do it.
Well, the class size is much smaller. Any online one? Mohammed, got it. Okay, so the primary constructor, right, is the constructor that is defined all together with the class definition. Well, if you got that wrong and you were listening to what I said, now you got it. You won't forget it, right? Because 2 chances, right? How many primary constructors can you define in a Scala class?
It's always the cheapest.
Wow, onliners. I should create 2 groups, onliners and then in-persons. See, get more questions right. Create a competition. Did I read? Okay. 73. Look at that. Only one. Can only have one primary constructor. Auxiliary constructors now. Come on, by elimination, 100%. Cardinal. I want to see the cardinal. Not this time. 0 or more, right? Those are the ones you create using this, right? You can have none, or you can have as many as you want, as long as they have different types, right? Or different number of parameters. They need a different signature. That one I just throw in there. This one was a disaster on my feedback data. Single table. Remember that drawing with the phases of the compiler? The single table was on the left, below. Got it, Daniel. 15%. So the symbol table will be more important for the semantic analysis, but it's built with information mostly from the syntax analyzer, right? And lexical analyzer will be able to recognize that something is an identifier, will give that information to the syntax analyzer. The syntax analyzer will put that into a context. Like this identifier is of int type. This is of string type, right? This identifier was created inside this scope, right? So all of that information is added in not only variables, okay, but also class definitions, function definitions, method definitions. All of these are identifiers. So remember the parse tree, you have inner nodes and leaf nodes, right? Okay, so variables and terminals. Okay, so variables are inner nodes, terminals are leaf nodes. Right? Good. So I'm still researching about that that problem with the context sensitive grammar, and I think that grammar is just complicated just to confuse us. That's my conclusion, because I found simpler grammar for that language. Okay, so that I wanted to share with you. Can I do something for the onliners? Let me see here. Is there a preset? Oh, because I'm sharing, right? So let me. There's like a white eagle one. Show the board. Oh, the camera is off now. What is saying no signal? Camera power. That's basic. Preset 4. Because I think there's a preset that focuses on one whiteboard. Oh, there you go. So preset 5. Preset 2.
There.
Hot.
But it's
It's pretty sweet, actually.
I can't see a thing.
It's this one.
Yeah, it's on the right board.
Okay, so 6.
What? Whoa. Fuzzy, extra fuzzy. Oh, one touch of the wide. Oh, way too wide. Oh.
So it's not the 4, right? That's 3.
There we go. That's the one.
That's it, right?
Nailed it.
Okay. So look at this grammar here. Problem now is the. So this one is the. Look at that, much simpler. Without all those like extra production, right? So if I want to do 3 A's, right? That's what we wanted to do, and 3 B's, 3 C's. So I would do S going to ABC. It's interesting, right, that we don't have any variable on the left side. We only have terminals. So it's kind of like really different from the grammars we were discussing. But then I'm going to replace AB with this. Okay, so I'm going to have AA, BB, C, and I'm going to repeat this C that I had. Okay, so now I'm going to do this again. I'm going to replace this AB here. Okay, so then I'll have A, so it's going to be A, B, B, and C, right? And then I'm going to repeat this, B, C, C. Okay? Now I'm going to do CB to BC, which is just flipping. All right, it's looking good. And now I just need to do this guy here into CCs. CC lowercase. And then I just need to do this again. Okay, so much simpler. So, well, that example, it was just overcomplicated. Maybe, possibly, just to confuse us. I just wanted to share that with you. It's an interesting problem. Now I want to move to the lexicon analyzer. I want you guys to work on the activity. Let me share my screen again. So we did activity 5, remember? Activity 5, the identifiers had a single letter. So basically, activity 6 is the identifiers are different. Identifiers start with the letter, okay? And after the letter, you can find letters or digits to compose the name. Okay? So I'll let you guys work on activity 6, which is that grammar, and finish the to-dos for the lexicon analyzer. And then I'm going to discuss another way to build lexicon analyzers using a tool called JFlex. So let's start with activity 6 now.
Yeah.
Yeah, yeah.
You're helping out with that.
Yeah, there was a workshop where they was at noon. That was the time I was teaching, so I couldn't join. But they're trying to find volunteers to work to streamline the process, the applications for people that are trying to leave Afghanistan. So they're going to use, I suggested using multiple, right? They're setting up a machine, but probably have to each write queries and maybe some. Yeah. Probably the application side because they will need to run queries and basic data input, validation. It's a great opportunity to learn how we want people here. Do we talk to you? I think it's best to, Klaus. Talk to Klaus. He's managing everything. I'm just giving a hand. You can just copy the code from this activity, so you don't have to repeat it. I shared the solution for activity 5. Okay, so all those parts starting at line 81, you can just grab it. Then you just need to focus on this part here.
That was not the right one.
Oh, okay. Some
Stuff, that was an 82. I'll admit.
Does that mean run this? Because I have three different. I'm trying to run lexical analyzer, but it's like I'm gonna run a whole bunch of free ones. I know that one doesn't work.
I got you.
So I'm trying to run this.
Configuration.
Well, I have separate activity folders for all my.
have a job on that, like.
Oh, but
With
but
running.
but that's how you
No, those are for test.
So hard.
So how do I?
They just copy.
Language is kind of nice.
Yeah, you see mine.
Any built tool is actually
I know it's like
Equal
Equal Visual Studios.
So this is right there.
This absolutely spoiled.
No, you copy and paste.
For like C sharp and.
Yeah.
Results are.
You copy
I can
all these files.
Yeah, I mean, I was just like highlighting.
Oh, you're doing.
Okay, so I am kind of remembering back.
It's best
Yeah, it's pretty
to
good.
clone the repository.
Pretty good.
Every time you switch
No,
on
they
data.
give me various aid, like.
I was trying to
Trash
clone
going around.
everything.
You just have to keep up with what the hell is
Oh,
going on in
there's-
.NET.
I have a GitHub character.
It's gotta be good, but other than that.
I thought when I'm cloning, because I tried cloning the homework, there was no like path.
the source file.
You have to clone the whole repository.
Yeah, so you have to go back and copy this.
Suppose there's just one repository for the whole.
So then I can pull every time, right?
Yeah.
This will everything, but you can literally just go, this is copy or paste into this.
What is it?
I'll clone it later because I don't want to.
Oh, well, I already have the source code.
So how do I?
Okay,
Yeah, you're gonna have to set up.
What is .exe?
So if you.
What is it?
I don't, that's not an option right
Folder,
now.
that's not set up, I just.
I don't like side projects. It feels like it thinks that it's supposed to be doing.
Yeah, so you make a new file, like call it Java or whatever.
Yeah.
.exe.
It will do that.
Okay, now, this is the part that needs to be changed because right now it assumes that if it has letter and immediately classifies that letter as an identifier. But after one letter, we need to see if more letters or digits are coming, right? We need to do similar to what we did here. Again, this is complaining that str is a val, so you change that to val. Okay, so as long as it's not in the file and what is coming is a letter or a digit, we keep getting the characters. Remember, get char does not consume the characters, so you need to call next char to actually remove and advance the input. Okay, so that's it. It's simple as that. So I got some questions about how to test your lexicon analyzer using the source code. Well, you need to run, if you're running this on IntelliJ, you need to run one time. And it will create a running configuration. And it says missing source file. So you need to go here and edit configurations. Look for program arguments. So I'm just going to use source 1x. That's the first source that we're going to evaluate. And as you can see, x2, right? So x2 should not be identified as x identifier and 2 literal because they are close together, no space in between. So x2 should be an identifier. And we got that, X2 token identifier. So let's try another source. This one here, Z99Z, right? That's an identifier, XYZ38. 38, it's also an identifier. What's the problem here? Parentheses, right? So this grammar is 6, right? This grammar does not have parentheses. No, there is parentheses here. Open parentheses, so we still need to do that, right? I haven't done that. So let's do that. Token. We need to create the tokens. So let's go to token, and we need to add these tokens. About open par. Open par. Open par and close par. There you go. So now it identifies the parentheses and closing. Anything else? Source 3 basically has new lines. Source 3. There you go. ABC, right? As an identifier, so everything worked just fine. Source 4 has a greater than symbol that shouldn't be recognized. It should throw an exception. Okay? All right, so any questions about lexicon analyzing? Yeah.
Isn't necessarily a question about it itself, but are you going to post the solution to this?
Yeah, I can post a solution for this one.
Okay.
And you guys have any questions for the homework? Let's review the homework. So the list of tokens for the homework sounds daunting, right? Oh, we jumped from how many? Like 5 to 10. But don't worry, most of them are keyword, right? So keywords are very simple to recognize because basically after you, in the code that you recognize identifiers, before you assume that that word is an identifier, you look at the map and see if you can find the keyword. If you find the keyword in the map, you return the token that the map will give you. So So the map associates the keyword to the token value. So if there is a mapping, you should return the value. If there isn't a mapping, you return the identifier, the token as an identifier. So it's pretty easy. Yeah.
I'm not super familiar with mapping in general, so how would you refer something to the map? How would you match something up?
Here. Yes. Okay. So you can use something very similar to this.
So you use a get, and then it still has a match statement with the map.
Yeah.
Okay.
Yeah. This is the str or the string, right? With the thing you accumulated,
Right.
characters you accumulated, you put it here. Match. Case sum. Token.
Would you just put the word token in there?
Yeah, like it's gonna be the variable with the
Okay.
token value.
Then it would, so then if it matches up
Then-
with
Return the string
string,
with the token.
if you just put token, would it then fill out the token dot class or token dot public?
Yeah, it
It
will
would.
replace the value associated with that key, which is a token value. And you just need to return that in a lexeme object.
Okay.
None, case none, what are you gonna do?
Return an identifier.
Return identifier, you
Okay.
got it. Okay? So, the provided code just use this big hint, which is this map here. The map is already created for you. You just need to use this map because the map associates the keyword with the token. So it's all there. You just need to add the logic here. All right? Any other questions for the homework? Let's do it Thursday.
That was my main question, because I was sitting there hard coding, turning each of those strings into
Yeah.
tokens. And I saw you had the map, but I had no idea how to use it, so I was just like, oh.
Yeah, you can do a bunch of if else, but because the map has this thing that I was talking about, the option,
I like the sum and the none.
yeah, and
That
that can be
makes sense.
confusing. So I would recommend you guys, I prefer you guys to use that example that I shared.
Is
in
that
my
under
resources?
resources? Okay.
It's under resources, Java guide, and then look for, just search for the part that has the class hierarchy. Right after that, there is the map example with the match. Or search for option T, options brackets T. Okay? Okay, so what's your take on Lex Analyzer? Isn't Lex Analyzer a very simple procedure? It's something that can be easily, you can easily write a program that generates the Lex Analyzer, right? Because it's, once you have a definition of tokens, it's just a matter of recognizing patterns, right? That's the important thing. If you write a program that basically recognizes patterns and replace those patterns by the token values, that's a Lex Analyzer, okay? So based on that understanding that Lex Analyzer is basically pattern recognition type of code, a long time ago, people created a program called Lex. Okay, so Lex was a program, I think it was created in the 80s or maybe even earlier. It was a GNU project. It became very popular. It was basically a program where you would write a specification of a lexical analyzer. So it wasn't a program. You write it you would write a specification, and then using the Lex, the program called Lex, Lex will automatically generate from your specification of the patterns and the tokens, it would generate a recognizer, or they call it scanner. So scanner is basically a Lex analyzer. So Lex was a program, an open source program that became famous that would automatically generate scanners, Lex analyzer. Okay. The code generated was a program, source code in C. Okay. And then the latest version of Lex, the project was refactored, and it became Flex. Okay, so Flex, if you're interested in scanners based on the C programming language, you can search for Flex. Okay, so you can find online easier. But since you guys are more familiar, that's my impression, you guys are more familiar with Java than C, right? So you're more comfortable with Java than C. I searched for an implementation of or similar program, but in Java, okay? And that's JFlex, okay? So let's learn about JFlex. And this is more to illustrate that, or to emphasize that you don't have to write a scanner from scratch. You can use tools, you can search online for tools that will do that automatically. Because nowadays, you need productive tools, right? So before you start creating a scanner from scratch, and of course in PPL, you learn how to do that because it's a specific course about programming language. So that's what we do. But in the future, if you, for some reason, you need to create a scanner, maybe you should consider using tools like Flex or JFlex, okay? So I wrote a small introduction of JFlex under resources. Yeah, so JFlex, there's the JFlex main website. Okay. There's also the JFlex guide. Okay, so Flex, as I was talking about, is the fast Lex analyzer generator, a software that facilitates the creation of Lex analyzer or scanners from the specification of tokens. So this was, as it was actually implemented in 1987, and Flex is the successor of Lex. Lex was actually in 1975. So JFlex was a port of Flex to Java in 1998, and we're going to talk about JFlex. So how to use JFlex? So JFlex so first of all, you need to download JFlex. So you go to this link. If you want, you can download, unzip JFlex. And what is important is the bin folder. So the bin folder, you need to add that to your path, environment variable, so you can run JFlex. Okay, so the code that will be generated, it uses the JFlex library, and it's all in Java. So in order to run your scanner after the scanner is generated from your specification, you need to add some libraries, and those are the dependencies you need. And you create, I suggest creating a Maven project in IntelliJ that will add all the dependencies. What you need to create a JFlex specification is learn the basics of JFlex syntax. And it's heavily based on regular expressions. And this is the things you need to specify. So there's these sections called user code, options and declarations, and lexical rules. So the user code contains Java code that you want to copy straight to the lexicon analyzer. So basically, when you want to do something more sophisticated, you use user code. So there are some directives like class. You want to specify the class name of the scanner, the code that is generated. You wanted to make it public. So all of these things you can just skip if you don't want to. If you just want to accept the defaults generated, you can just skip user code, and that's what we're gonna do. State definitions are more important. That's where you can specify the patterns. And then the lexical rules can take many different forms specifying in EBNF. Mainly, they will make the association between the pattern and what you should do, the action, which is basically the return value. What do you want to do when the pattern is recognized? What are we doing? Here we're just printing the lexeme string and the token value. So let's do the same thing. And for that lexicon analyzer that we wrote in Scala to recognize basic arithmetic expression, this is how a flex specification would look like. Okay, so it starts with some directives here. So class, I want my lexicon analyzer class, generated class, to be called lexicon analyzer. So class lexicon analyzer. The type returned by the scanner whenever a code, whenever a pattern is recognized, is going to be a lexeme object. So I'm defining this type here. I forget what debug is. And then you have the patterns. Look, this is how I'm going to recognize spaces. So the spaces is a regular expression that says a space or a tab or a new line 0 or more times. That's a regular expression that defines what is a space, or characters that should be ignored from the source code. Okay, so look at that. Look at the action. Here we put the pattern and the action. What is the action associated with the space? No action. It means what? Ignore. Okay, so literal. A literal is digits, right? 1 or more times. This is how a literal is, regular expression is defined. What is an identifier? A single letter, lowercase. So that's for the activity 5, right? Activity 5, the identifier was just a single letter. And we also have like the addition. So if I recognize an addition, I'm going to return the text, the symbol, right? And the token addition. So it's, you see, I'm returning the lexeme objects pretty much the way we did when we wrote the parser manually, right? Or from scratch. But this way, we're basically writing the specification. And then we're going to click a button or run a code, and JFlex will generate the code for the scanner for us. So that adds productivity for us. Okay? When it reaches an end of file, just return the end of file token. So don't you guys agree that this is something easy to read, right? And express all you need for the lexicon analyzer. So let's use this specification. And again, I'm not worried that you guys would study this and understand a JFlex syntax in order to specify scanner specification. I'm not expecting you guys to do that. This is more like a curiosity to show how to create a scanner using a tool, okay, a third-party tool. So let's run this. So let me do this. I'm going to create a new project. And this is a Java project, it's not Scala anymore. Maybe we should create a S-Flex, right? Scala Flex. So this project is actually, you should actually create a Maven project because there is dependency, okay? So I'm going to create a Maven project and I will wait. Why is this taking so long? Loading archetype list. Okay, so this was a Maven project. And let me find a folder for this project. Teach PPL in class. Let's create a folder. How about activity 5 JFlex. Okay. And I should grab the dependencies. Just gonna paste it here. Click refresh, so that will download JFlex libraries needed to run the scanner after the scanner is generated. And we should put the specification. So how about we create it here? So we create a file called expression.jflex. It's a text file. I'm going to open this file and I'm going to just copy this example here, okay? Okay, just going to open the terminal now. And I'm in the same folder where JFlex is, okay? So I just need to run JFlex. So let me see if JFlex is in the path. It is. If you run JFlex without parameters, you're actually going to get a GUI. Look at that. But if you don't want the GUI, you can just do JFlex and then the specification. So lexical specification. This guy here. And we can just click generate. 0 errors, 1 warning. Generation finished successfully. Quit. Where's my code? lexicanalyzer.java. Okay. So I'm just going to move the generated code to here. Okay, so that's the code. The code has arrows because I need to grab the code for the Lexeme, right? All those other classes. So let me grab that code. I know where I put this code, so let me just grab that. The Lexeme.java is basically a port translation of Lexeme Scala to Java, okay? Symbol is the same, and then token. So I'm just going to copy those to class, view flags, okay, so the error is gone, and the only part of the code that I didn't write was the Lex analyze. This code was generated by JFlex. Okay. Well, I think my code is better than this. That's the code, and I can potentially run it. Where's main? That's a lot of lines. Okay, here's main, and as you can see, main expects input files. So maybe we should copy those expressions, remember? So let's copy those from activity 5. Okay, so let's try to run it, see if it works. Okay, so it's expecting the input files. So let me give one to them. So source 1 ESP. Run it. Okay, so and it worked. Look, first match was 52, and it was recognized as a literal. And then addition, you see? What's that? Was a space ignored, you see, space ignored. And then X was an identifier, multiplication, so it worked perfectly. Okay, so how would you guys modify that specification in order to recognize identifiers that begin with a letter and can have letters or digits without writing anything? Like, you just need to change the specification, right? The way you specify an identifier, the identifier regular expression, it needs to start with a letter. And after that, it should have letters or digits. How would you change that?
Couldn't you refer to literal since it contains all of the digits? Or that?
Or you can, because you need to start with a letter, you have that, right?
Right.
Maybe you can put in a group, right? It can be a letter, right? Or a digit. 0 or more, right? So that will be the pattern for identifiers. without coding. You just need to change. Imagine you have a very, a much more complex grammar, right? So that tool would be very helpful in those situations.
Rather than hard coding for every single case.
Writing,
Yeah, that would
writing
take
the
forever.
scanner from scratch. You just specify the patterns. Okay? So for your project, for the assignment, I'll give you the option. You guys can use Lex Analyzer like we were doing here from scratch. Or if you want to learn more about JFlex, you're also welcome to use JFlex. But then the code will be in Java, right? And I wanted to use Scala.
Yeah,
Uh,
they didn't make a Scala flex, did they?
yeah. So, well, we learned that Scala can use Java code, right? So your syntax analyzer might be in Scala. I haven't tested that. You guys can do that.
This sounds.
You can have the syntax analyzer in Scala and your scanner in Java. It should work, okay? But I haven't tried. But if you want to learn something new, if you want to try those things, I think it's cool. Maybe bonus points, maybe some incentive. Okay, so let's test that. For example, source one. You see a good source code for testing that. So ABC should be recognized as an identifier, right? If I run it now, source 3, it should recognize 3 identifiers. So let's run that before we change the scanner, so we can see the difference. Okay, so you see here, A, B, C. Each of them was recognized as an identifier. So now let's change the scanner based on this new specification and regenerate the code.
The output's kind of cool.
So you can also just run through the command lines without the GUI. So let me just pass expression JFlex and it worked. Look at that. Constructing NFA, non-finite automata. See what you learn in theory being applied directly here in the tool. 24 states. Okay, so I'm going to run this again. And let's see if it will recognize the 3 letters as a single identifier. No, it's still the same.
It outputs it in that root folder.
Oh, okay. Oof. I'm going to remove this guy. And I'm going to move it. Let's try again. Look at that. Woohoo! ABC identifier. Well, just by changing the pattern, you were able to generate a new scanner without having to write code. I know you love to write code, but this gives you productivity. Okay.
Take that.
So what's next? Syntax analysis.
Before we move on to this next thing, can I ask a quick question about
Yes.
the homework?
Yes.
So I don't know if we covered this or not, but I'm not able to get it to build because of the 2 Java files that start with an underscore. It won't compile, so I can't run it to test.
2 Java files.
5 and 6.
Source 5 and source 6 and the homework 3 won't compile because
Looks like you need to go to office hours. I think it's trying to move the source directory.
source, which one?
Source 5 and source 6. I haven't been able to test the homework because
Oh,
it,
okay, so basically, you can have a identifier that starts with underscore. And they can contain $.
right, and I have that in my code, but I can't test if my code works because IntelliJ won't even run the code. Because these source files are starting with, well, I'm not running the .java file, just running lexical analyzer.scala. It's not, it's trying to.
I think your Java files are looking fine. Things as a source directory.
Okay, so do I have to,
Yeah, I think you need to mark that as source directory.
instead of, okay, let's try that, okay.
It's trying to
I
build
moved
up
up like
like
a
it's
Christmas tree as soon as I could.
Yeah, those are parameters for your scan. Right? Although they have Java extension, we're not going to run these code. They're just dummy codes for you to test yours. And this code is, of course, it's not synthetically correct. But you should be able, the lexical should be able to recognize this as an identifier, this as a keyword, this is a closing braces, and then
Then it
greater
crashes.
than it crashes. Okay? It should crash. This
The changing the source directory worked for me.
okay.
So I've got, yeah, progress.
So just going to start this, but I don't like to start a new topic like 3 minutes to finish. But basically, I just want to say that in this class, there are many different types of parsers. But this class is not a compiler's class, so we don't go as deep understanding and studying different parsers. But what we're going to do, we're going to discuss 2 different parsers, okay? And I chose them because they have completely different approaches. One, the approach is analyzing the code, or not analyzing the code. The way, the difference is basically how the parse tree is built, okay? The top-down parser builds the parse tree top-down, as the name suggests, okay? So from the start symbol, it moves down to the leaf nodes, okay? The bottom-up parser builds bottom-up, so it starts with the leaf nodes and connect them together until it reaches the start symbol. Okay, so it's interesting, in my opinion, because you see the 2 approaches. Okay, and then you can compare those 2. The specific top-down parser that we're going to discuss is called the recursive descent parser. Okay, so as the name suggests, it has a lot of recursive functions. The functions will call each other, and sometimes a function will call itself depending on the production you're trying to implement. Okay, so if you have something like something like A goes to AA, that's recursive. Okay, so you have a function that will evaluate an A calling itself. Okay, and we're going to see that the recursive descent parser, if you're writing the code from scratch, again, there are tools that generate the parser for you, but we're going to write from scratch to learn how to do it. The recursive descent parser, you have to write a lot, but once you figure out how to write one method from a production, the procedure becomes repetitive. Okay, so the first time is kind of hard to understand, but then once you get it, it's basic repetition. So if you want to use this type of parser for your assignment, just keep in mind that you're going to write a lot of code, but the code is simple. Okay. The other approach, the bottom up, you use another tool. I'm going to talk about this tool that creates a state machine. And your parser basically uses the state machine that is generated to run the code and to implement the parser, basically. Okay? So it's like the state machine is one of the parameters of your parser, but the code of your parser is much smaller because much of the logic is in the state machine. Okay, so you have these two approaches. One, you don't have a state machine, you have to write a lot of code, the code is simple. The other one, the code is more complex, but it's much less and is based on a state machine that you can auto-generate. So you're going to have these two options. Okay, if you just want to write a lot of code that you don't want to think much about it, you do the recursive descent parser. If you want to, if you like theory and you want to use the knowledge that you acquired during theory and use the state machine as an input for your parser, maybe you're more into the bottom up. So 90% or more, usually they pick the recursive descent parser. Just a few tried the other one, but we're going to see both, okay? All right? At least for small examples. For the programming assignments, you get to choose, okay? All right, guys, so we start this on Thursday.
Oh, please, what's that?
Yeah, that's right. That's why I'm learning it right now. Say we acquired it well. Oh, you're saying we just did acquire things.
You have no idea where I like to step in a water.